Hello friends, this is your physics lecture delivering by Talli Madam. In this video, we see another important topic for JEE NEET, that is charging and discharging of capacitor. When the capacitor is connected to the external battery, that we called as a charging. In the charging, different conditions are there. First, when the capacitor is just connected to the external battery or the switch is just closed, that is initially at time t equal to 0, charge on capacitor is 0 and potential difference across capacitor is 0. At this condition, capacitor act as a short circuit. So when the capacitor acts as a short circuit, the current through the capacitor or current through the circuit is maximum, that is V by R, which we consider I naught. The second condition is after some very short time, a capacitor start charging. That is positive charge start acquiring on the first plate, negative charge starts acquiring on the second plate, potential difference start building, it will start increasing. At this condition, whatever the potential difference is across R as well as across capacitor is there. So total potential difference V is the potential difference across resistor plus across capacitor. So if I want to find the potential difference across a resistor, that is nothing but total V minus Vc. Okay, so V minus Vc, the Vc is nothing but potential difference across capacitor, that is Q by C. What is the potential difference across resistor? It is I into R. So what the I is? I is nothing but V minus Vc, that is Q by C divided by R. So this is how we can find the current in the circuit when the capacitor is charged. Okay. So when we rearrange this equation, we get a charging equation of the capacitor. Now in this state, you have to remember during charging, whatever the potential difference across the capacitor starts increasing, but current start decreasing. Initially current is maximum. When the capacitor start charging, the current through the circuit start decreasing. Okay. So whatever this state during charging state is called as a transient state. Remember, this is a transient state. Another important condition for the charging of capacitor is when capacitor is fully charged. After some time, capacitor is fully charged. When the capacitor is fully charged, the complete potential difference or the voltage of the battery is come across the capacitor. So voltage across the resistor is 0 as the current through the circuit is 0. Now when the current is 0 and complete potential difference is there across the capacitor, at this condition the capacitor act as a open circuit. Okay, so whatever this condition is called as a steady state. So you have to remember, in the steady state, the current through the capacitor is 0, capacitor act as a open circuit, and initially when capacitor is just connected to the external battery, at time t equal to 0, capacitor act as a closed switch or short circuit. Okay. Now by taking the intermediate, that is transient state equation, current I is equal to V minus Q by C divided by R. What is the current I? It is dQ by dt. So rearrange the equation, solve, we get from this equation we get Q is equal to Q naught 1 minus E raised to T by R minus T by RC. So here whatever the value of Q naught is nothing but C into V, which is nothing but maximum current or maximum charge acquired on the capacitor, and whatever the value of RC is nothing but the time constant. So RC is called as a time constant tau. Now this is the equation of the charging of capacitor. Q is equal to Q naught 1 minus e power minus T by RC. Put different values of t here. Put t equal to 0. E power 0 or e power minus 0 is nothing but 1. So 1 minus 1 is 0, that is Q is 0. That is we already considered at t equal to 0, Q is 0. Put the value t is equal to infinity. What is e power minus infinity? It is 0. So what is Q? Q is equal to Q naught. Now put the value of t as a 1 tau. So this is called as a one time constant. So when the value of t is one time constant, that is nothing but RC, what is E? E is nothing but minus 1. So e power minus 1 is nothing but 0.37. So put this value in the equation of charge, we get 1 minus 0.37 is nothing but 0.63 q naught. So these are the different values of the charge at different condition. From this we can draw a graph. Okay, now if I want to draw a graph of charge versus time, so what this graph is, at time t equal to 0 charge is 0, at time t is infinity charge is maximum, means the charge starts increasing and it is maximum or it till constant at t equal to infinity. So this one is the graph of charge versus time at t equal at different condition of the time. So here we can show at 1 tau, that is one time constant, the charge is 0.63 q naught and it is maximum at t is equal to infinity. Okay, from this we can build another equation, that is the current. So the first one is charge q is equal to q naught 1 minus e power minus t by rc. Second equation, what is the current? Current is equal to dq by dt. When we differentiate this equation, we get it is I naught e power minus t by rc. What is I naught? I naught is nothing but maximum current, and the maximum current in the circuit is V by R. If you put the different values of time here, t equal to 0, E0, it is 1, so it is I is equal to I naught. Put the value t is equal to infinity, you will get I equal to 0. And if you put the value t is equal to 1 tau, that is one time constant, you will get I is equal to e power minus 1, means 0.37 times maximum current, right? So if you want to draw a graph of current versus time t, this graph becomes, initially it is maximum, that is I naught, and after that it is minimum, means the graph is decreasing like this. Okay, so the current versus time graph is this one, and such graph can be asked for your exam. Next, another equation we can build from this is the Vc, that is potential difference across capacitor, which is nothing but charge upon capacitor. So V is equal to V naught 1 minus e power minus t by Rc. Okay, so V is equal to V naught 1 minus e power minus t by Rc, where V naught is maximum value of the potential difference across the capacitor, which is Q naught by C. And as this equation is same as the equation of charge, so the current so the potential difference versus time, the graph is same as the graph of charge. The fourth factor which is mostly used or asked is about energy. Energy stored in capacitor is q square divided by 2c. What is the maximum energy? It is maximum charge q naught square by 2c. So when we want the equation of energy in terms of transient state E naught, it is 1 minus e power minus t by rc bracket square. So if we expand this, we get 1 minus 2 e power minus t by rc plus e power minus 2 t by rc. Sometimes the rate of energy is also asked. So what is the rate of energy? The rate of energy is nothing but just differentiation, that is derivative of energy with respect to time t rate. Right. So just differentiate this equation, or remember it is v square by r 1 minus e power minus t by rc into e power minus t by rc, like this. Okay. Another one, the question can be asked on the power. So there are two types of power, that is power through the source or the battery is given. The power through source or the battery is asked, then we use the formula V into I. If the power dissipation, that is the power through resistor is asked, power dissipated is asked, then we use the formula I square by R. So these are the different formulas we use while solving the examples on the charging of capacitor. Remember. Thank you.